Okay, so state question 15. State the principle of moments. Now, with the principle of moments, the clockwise moments equal the anti-clockwise moment. Unfortunately, that will only pick you up 1 mark because it should read the sum of the anti-clockwise moments equals the sum of the clockwise moments, providing that the object is in equilibrium. So that is vital as well within your definition and something that you need to recall and remember. So the next question, we're going to use the principle of moments, the one that we've just defined, to answer this question here. And I am just going to remove this and make this into a bigger screen. So we've got a spring that's lifting this ruler upwards, and I've added an arrow for the direction of the force that the spring is exerting. You've got the weight of the beam acting downwards as 5 newtons, and then we've got a little bit of a weight here of acting downwards of 2 newtons. And there's a pivot point. Everything is rotating around this pivot point. So this entire beam is pivoted at this point here. And we know that all moments need to be calculated with a distance from the pivot point. So the principle of moments, sum of the clockwise moments equal the sum of the anti-clockwise moments. And what we're trying to find out is the force that this spring is pulling with, i.e. the tension in the spring. This force here creates a clockwise moment around the pivot point. There's a distance from the pivot point. There is the force. So that will create a clockwise moment. And these two forces will create an anti-clockwise moment around that pivot point. So the clockwise moment is the tension in the spring multiplied by distance from the pivot to that force, the perpendicular distance from the pivot to that force, which is 0.03, and then that's equal to the anti-clockwise moment. So 5 newtons times by the perpendicular distance to the pivot, which is 0.24, and that's added to the other anti-clockwise moment, which is 2 newtons multiplied by the perpendicular distance to the pivot, which is 0.47 meters. And then we rearrange for T and we get the tension in the spring pulling upwards is 71.3 newtons. So if this object is to remain in equilibrium with the net force of 0, then what we'll have is this upward force acting on the spring to hold this entire object in equilibrium is 71.3 newtons.